In this demo video, we'll be covering some of the behavior and code regarding Ingest-Materialize-Index architecture exemplified by the project available at atleon.io/IMI-demo. This architecture diagram illustrates the wiring of the demo that we'll be showing off today. In this case, we'll be leveraging the concepts of companies and hiring intents as sources of data that are used to materialize views called job posts, which are used to advertise the need to hire to potential job seekers. In this case, companies and hiring intents will produce events that we use to ingest into our application, which we extract the carried state from those events that we care about and cache it, subsequently generating materialization commands, which trigger our materialization process to read that cached data and use it to generate the job posts that subsequently go on to a materialized view topic. Lastly, those materialized views drive our indexing process, which in our case will be logging those views so we can see the result of materialization. First thing I'll do is go ahead and get our cloned app running. And while that is starting up, we'll look at some code. The first thing to look at is our implementation of ingestion. This class neatly encapsulates what it means to implement ingestion. We first start off with some arbitrary or abstract source of events that we are ingesting. We apply some arbitrary concurrency to the processing of these events. We subsequently apply an IO-bound process of ingesting those events, which the result of ingestion is the materialization commands. Those commands are subsequently sent to Kafka using a sender, and then we have some quality of service operators that you will see in all streams, one for catching all errors that we don't explicitly handle, one for cleaning up any resources when the stream gracefully shuts down, and then finally triggering subscription and processing of the stream with a subscription operator. You'll note that this ingestion stream, while producing to Kafka, is not constrained to consuming from Kafka. It can consume from virtually anywhere. In fact, our company events are modeled with an SQS queue. In this case, we build an SQS receiver, which is capable of deserializing our JSON objects. All we have to do is feed it our deserialization configuration, as well as an SQS queue URL to consume from. We'll also take a quick peek at what it means to ingest. Our ingestion process extracts some of the carried state that we care about, upserts it to our cache, and then uses our cached hiring intents, if we have any, to figure out what hiring intent commands or materialization commands need to be rematerialized. Our materialization process, arguably the most heavyweight and complicated of this architecture, nevertheless fits in a neatly encapsulated stream definition. It starts off with building a receiver of commands, which you will, if you are familiar with Kafka, which I believe everybody here should be, that receiver is built with some common configurations, including a client ID, consumer group ID, key and value deserializers, etc. Those deserialization and reception configurations are used to create that receiver and receive commands from our command topic. We apply some arbitrary amount of concurrency. We also apply micro-batching, which in this line is characterized by our batch size and our batch duration. We take either batch size or T duration of elements, whichever one comes first. We then apply some IO-bound materialization operation on each batch of commands. The result of materialization is a view that we wrap as a producer record and then subsequently send to Kafka. And again, you have our quality of service operators along with a finishing subscription that triggers our stream to start processing. We'll take a quick look at materialization. Materialization is broken up into two logical steps, the first of which is dereferencing the data that we care about. The materialization commands themselves reference the hiring intents. we get those hiring intents, and then look up all the company IDs we need for the company data we need to dereference, perform that dereferencing, and then generate the job post based on all of the data we have just aggregated. Lastly, once those views are produced, we have an indexing stream. Similar to our other streams, we have a receiver that we build. We receive the views from our materialization topic. We apply some arbitrary amount of concurrency. We apply some IO-bound indexing operation, and then we terminate with some quality of service and subscription operators. Now that we know what the code looks like, let's go ahead and check out what's going on over here. We see that our application is running. We will go ahead and use a REST endpoint to manually produce our events. The first thing that we will do is create a company called Confluent with the ID of 1. We see that that was successful and that our application did some processing. It hasn't materialized any views yet because we haven't created any hiring intents. We will go ahead and do that now. In our case, we will create a hiring intent with the ID of 1 and referencing the same company ID for the Confluent company we created earlier. The job title will be software engineer, and the description will be to stream all the things. What we see on the right-hand side is our application indexed a view for the hiring intent that we just created. It contains information from both the hiring intent and the company, including the company name and the job title and the job description. For completeness, we'll go ahead and create another hiring intent. This one will be for a staff software engineer. And as we all know, as you move up in the software engineering ranks, you are no longer implementing all of the things, but you are rather refactoring all of the things. And we see another index view for our new hiring intent. Let's also show what happens if we were to change our company name. In this case, we said our company name was Confluent. Let's change that to Confluent Inc. And what we should see is that both of our previously indexed views are re-updated because data about both of them has changed. And of course, what we see are two updated views, both for our software engineer and our staff software engineer, and both containing the updated company name. Thank you for listening.